In this video, I will walk through an example with an absolute value inequality, but I'm also going to give an overview of how to solve an absolute value equation, less than inequality, and greater than inequality. So here's the process in general. If you could see here on the right of the screen, when we have an absolute value that's equal to some value, let's say 10, then we could see that either a negative 10 or a positive 10 would solve that inequality. So we can see that x is the opposite of 10 or x equals 10. Both of those numbers would solve this inequality. The absolute value of x is 10, then the absolute value of negative 10 is 10, and the absolute value of 10 is also 10. Now, when we see that the absolute value is less than 10, it's important to remember that absolute value means the distance from 0. So what we're saying is we want all the x's whose distance from 0 is less than 10 units. So we could see that we could stretch out to the opposite of 10 or 10 and sandwich in. So this, all the x's that are less than 10 or all the x's that are greater than negative 10 are going to be included. Notice that we've got a parenthesis at the 10 and negative 10 because the 10 and the negative 10 aren't included. Now if I put a or equal to, I would have used a bracket here. But let's keep these two just the less than or just the greater than and not include the equal to. By the way, if I wanted to translate this to interval notation, I could pull it right off of this number line, and it would be negative 10 to 10 exclusive, or in other words, parenthesis, negative 10, comma 10, parenthesis. This is not an ordered pair. What we're saying is we're going to start at negative 10 but not include it and go up to 10. So it's that part that's shaded on the number line. Now if we did an absolute value of x that's greater than 10, remembering that absolute value means distance from 0, we're going to start at negative 10 and go out, or start at 10 and go out. Now, if I kept going and going to the left, I'd get to negative infinity or positive infinity to the right. So what we can see if we just pulled these values right off of the number line, the absolute value of x greater than 10 would solve with the interval from negative infinity up to, but not including 10, or, so I'll use a union symbol, which translates to or the interval from 10 to positive infinity. Notice that I'm not including the negative 10 or 10, so I use a parenthesis. And whenever we have an infinity or negative infinity, it's always a parenthesis because you never include that. You can't ever get to infinity. So let's look at our example here. We've got the absolute value of 5 minus x times negative 9 is less than negative 27. Right off the bat, the easiest thing to do is to divide both sides by negative 9. The reason I'm doing that is I'm going to simplify this absolute value expression, or I'm sorry, inequality. I'm going to simplify it by isolating this absolute value. Now, when I divide by a negative 9, notice that that less than is going to change to a greater than. So now what we're looking at is the absolute value of 5 minus x is greater than positive 3. So if I could picture that on a number line, we're going to start at negative 3 and go out to the left to negative infinity, or from 3 and go to the right. But let's solve this inequality. And to solve it, we're going to say that this 5 minus x is less than negative 3, or 5 minus x is greater than positive 3. So you see this 5 minus x less than negative 3 is this interval. 5 minus x greater than 3 is this interval. When I solve for x, I've got the negative x is less than negative 3 minus 5, so subtracting 5 from both sides. So negative x is less than negative 8. And now I'm going to divide by a negative, right? So when I do negative x divided by negative 1, I've got to flip the inequality to be greater than, and then divide the negative 8 by negative 1. So this gives us x greater than 8. There's the first part. Or, doing the same thing to the right, subtract 5 from both sides. 3 minus 5, negative 2. When I divide by a negative 1, I'm going to flip the inequality from greater than to less than, positive 2. If I were to put this final answer on a number line, looks like we're less than 2 and we're greater than 8. Do you see how you could shade that? We're going to start at 8 and go to the right, or start at 2 and go to the left. So if I wanted to write this in interval notation, you can see that way off to the left I'm going to negative infinity, way off to the right going to positive infinity, pulling this right off of the number line. I've got the opposite, negative infinity, up to positive 2, exclusive, because it's not or equal to, right? If it was or equal to, we'd have a bracket, but we're going to use a parenthesis, or 8 to infinity. But do you see how that follows the same pattern we had for this general greater than inequality? I hope that this video helps you better understand how to solve this, not just this example, but other examples like it. And try some other practice problems and make sure that when you practice this on your own, you're still getting the accurate answer.